By the end of today's lesson, you should know what is meant by a complex number and why they are necessary to solve some equations, and to be able to add, subtract and multiply complex numbers. If you see notebook in the top right hand corner of the slides, please make sure that you copy over the notes to your notebook for revision purposes. Have a go at this activity. Stop the PowerPoint before going through some answers. Okay, I'll reveal the answers here, but then go through some worked solutions to these on the following slides. Now I'm going to go through the worked solutions to parts A to D. Part A, x squared is equal to 9. If we take the square root of both sides, we have x is equal to the square root of 9. Don't forget here we have the plus or minus of both of these. So we have x is equal to 3 and we have x is equal to minus 3. Let's take a look at part B. Now I can factorise the left hand side here. So we've got a 6, two numbers that multiply to give 6 and add to give minus 5. I'm going to put the x in both brackets to begin with. So that would be minus 3 and minus 2. We then have x minus 3 is equal to 0 and x minus 2 is equal to 0. If I solve both of these, I have x is equal to 3 and x is equal to 2. Part C. Okay, let's take a look at part C. This one, again, can be factorised, but obviously you can complete the square with this or use the formula, it's up to you. So, two brackets, we've got 2x squared, so we're going to put 2x in this first bracket. Two numbers that multiply to give minus 1, and this time we need to look at the cross multiply to see what gives us the 5. So this would be 3 and 1, so we've got minus 1 plus 3. And if we solve both of those brackets equal to 0, and then rearrange, so we've got 2x is equal to 1, x is equal to half, and here we've got x is equal to minus 3. And then lastly there, part D. So we need to do a little rearrange here first of all to set it equal to 0. X squared plus 8x, take 4 is 0. And this time I'm going to complete the square. So we have x plus 4 all squared, subtract 16, subtract this 4. So that is x plus 4 all squared, take away 20. And then if I do a little rearrange here, so we have is equal to 20, I can start to take the square root. So I've got x plus 4 is equal to the square root of 20. And don't forget the plus or minus on that. And then finally we've got x. We take the 4 across to the other side, so we've got minus 4 plus or minus. Now here the square root of 20, that can be simplified using z to 2 root 5. Let's have a go at solving E, F and G. Looking at part E, we have x squared is equal to minus 16. So x will be equal to plus or minus the square root of minus 16. Now if I factorise out the minus 1 here, I can rewrite that as the square root of 16 multiplied by the square root of minus 1. And it's that minus 1 that we'll take a look at very shortly. In your calculator, this would give you a maths error. So the square root of 16 is 4, so we have 4 multiplied by the square root of minus 1. Now for part F, I'm going to have a go with completing the square here. So we've got x minus 1 all squared minus 1 plus the 2 equals 0. If I simplify that, that gives me plus 1. And then take that across to the other side, gives me the minus 1. So this part here is where the problem will arise, being negative. Taking the square root, so I've got x minus 1 is equal to plus or minus the square root of minus 1. And therefore x will be 1 plus or minus the square root of minus 1. And again, it's this part here that we'll take a look at on the next slides. And finally, G. This time I'm going to have a look at the formula. So we have minus b plus or minus the square root of b squared minus 4 times a times c, all over 2 lots of a. Simplify this, we have minus 4 plus or minus the square root of 16. 4 times 3 is 12, times 2 is 24. Again, we can see we're going to have a negative value under our square root, which is where the problem will arise. I've just seen that I've written a there, so let me just rub that out. So that should have been 3, which gives us a 6 as the denominator. Now simplifying underneath that square root, we've got minus 4 plus or minus the square root of minus 8 all over 6. And a little bit of simplification here again. So we have minus 4 plus or minus 2 root 2, which is the square root of 8, multiplied by minus 1 all over 6. And then I can start to simplify here. So there's a factor of 2 in 4, 2 and 6. So this will simplify to minus 2 plus or minus the square root of 2 multiplied by the square root of minus 1 all over 3. Let's take a look at what a complex number is. Here is the positive x-axis. This set of numbers is called the natural numbers and is denoted by the letter n. Extending this set of numbers backwards to include 0 and negative numbers, we now have a set of numbers called the integers. This is represented by the letter z. Z for Zahlen in German means numbers. Now we can fill all of the gaps on this number line with another set of numbers. Here we have fractions and decimals, and these make up the rational numbers, which are denoted by the letter Q for quotient. Now there are still gaps on this number line. These can be filled with the irrational numbers, such as root 2 and pi and all multiples of those. As soon as this is done, we now have a set called the real numbers, which essentially means that that straight line, the x-axis, is now complete with no gaps. We can extend the x-axis now into the y-axis. When we take a look at numbers when squared that give us a negative result, we can map these onto the y-axis. If the x-axis represents the real numbers, which we denote by RE, then the y-axis represents what we call imaginary numbers, IM. And it's these two sets of numbers combined that make up the complex numbers. And here we denote the square root of minus 1 to be I. Okay, so the complex numbers are denoted by a C, and they consist of a real and an imaginary part. Let's take a look at one now. Here we have the complex number 4 minus 3i. Very similar to coordinates, 4 across and 3 down. This one, we've gone 6 across and 1 up, so this will be 6 plus I. The general case for a complex number can be written as z is equal to x plus yi. Let's take a look at adding and subtracting complex numbers. If z1 is equal to 2 plus 3i and z2 is equal to 5 minus 2i, let's take a look at what z1 plus z2 would be. So we have z1 and plus z2. Now if we take a look at the real parts first of all, so we have 2 plus 5, this gives us 7. And then let's take a look at the imaginary parts next. So we've got 3i take away 2i, and that gives us plus I. Next, 2 lots of z1. So we have 2 multiplied by z1, 2 plus 3i. And here we need to multiply this out, so we've got 2 multiplied by 2 and 2 multiplied by 3i. This will give us 4 plus 6i. And lastly, 3z1 take away 2z2. You might like to try this for yourself. I'll start with the first step, but then pause the PowerPoint to have a go yourself before I go through the answer. So 3 lots of z1 plus, subtract 2 lots of 5, take away 2i, 2 lots of z2, and then we need to multiply this out. Have a go now. Okay, here's the answer, minus 4 plus 13i. So, did you get that? So we have 3 times by 2, which is 6. And from this one we have minus 2 times by 5, which is minus 10. So minus 10 plus 6, this gives us the minus 4. And then looking at the imaginary parts, 3 times by 3 is 9. Minus 2 times minus 2i is plus 4i. So we have 9 plus 4i, which gives us the 13i. Okay, so if you are adding, subtracting, or multiplying by a scalar, you need to evaluate the real and the imaginary parts separately. Okay, let's take a look at multiplying complex numbers. Z1 multiplied by Z2. The same rules of algebra apply to complex numbers as quadratic equations. So here we have 2 plus 3i multiplied by 5 take 2i. We multiply the terms out just as we would 2 times 5, 2 times minus 2i, and 3i times 5, and 3i times minus 2i. And this, when simplified, should give you 10 plus 11i, take away 6i squared. If we look at Z1 squared, so we have 2 plus 3i multiplied by itself, 2 plus 3i. We apply the same rules again, so 2 multiplied by 2, then 2 multiplied by 3i, 3i multiplied by 2, and 3i multiplied by 3i. This simplified will give us 4 plus 12i plus 9i squared. Okay, this is what I mentioned a moment ago. So if you're multiplying complex numbers, you expand brackets using the same rules as algebra. And it's important now where we see this I squared, we know some extra information about this. So I squared is equal to I times I, which is the square root of 1 multiplied by the square root of 1, which is minus 1. So now we can substitute this in for where we see I squared here and here. So we now have 10 plus 11i, take 6 multiplied by minus 1, which will simplify to 16 plus 11i. And the second one there, 4 plus 12i plus 9, and here we're substituting in the minus 1 where the I squared is, and this will simplify to minus 5 plus 12i. Now it's your turn. If Z1 is equal to 5 plus 3i, Z2 is equal to 4 plus 2i, and Z3 is equal to 6 minus I, have a go at solving the questions below, parts A to I. Stop the PowerPoint now before I reveal some answers and then go through some work solutions. Okay, here are the solutions. Right, I've just picked D, G and I for 3 questions for me to go through work solutions. So let's have a look at how these would look. So we've got 5 lots of Z2, which is 4 plus 2i. Subtract 2 lots of Z3, which is 6, take away I. Now multiplying those out, so we've got 5 multiplied by 4 is 20. 5 multiplied by 2i is 10i. Minus 2 multiplied by 6 minus 12, and the minus 2 multiplied by minus I is plus 2i. Let's simplify. So we have the 20, take away 12, this gives us 8, and 10i plus 2i, which gives us 12i. Part G, so z2 multiplied by z3, we have 4 plus 2i multiplied by 6, take away I. Multiplying these out, 4 times by 6 is 24. 4 times by minus 1 is minus 4i. 2i multiplied by 6 is 12i. And 2i multiplied by minus I is minus 2i squared. I'm going to simplify the middle terms and substitute in minus 1 for I squared. So that gives us 24 plus 8i minus 2 lots of minus 1. Minus 2 times minus 1 is plus 2. That gives us 26 plus 8i. And finally, z2 cubed. So I'm going to start by looking at z2 squared. That's 4 plus 2i multiplied by 4 plus 2i. This gives me 16 plus 8i plus 8i plus 4i squared, which simplifies to 16 plus 16i plus 4 lots of minus 1, which is 12 plus 16i. And it's this that I will then multiply by the third lot of z2. So I've got 12 plus 16i multiplied by z3, which is 6 minus, wrong one there, so that's multiplied by 4 plus 2i. Multiplying these out, 12 times by 4 gives 48, 12 times 2 is 24i, 16 times by 4 is 64i, and 16 times by 2 is 32i squared. Simplifying again, so I've got 48 plus 88i and then plus 32 multiplied by minus 1. This overall will simplify to 16 plus 88i. Now later there will be a faster way that you can multiply these out, but for now just using algebraic terms will do just fine.